Hello friends, this video on Ray Optics Part 27 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 26 before going ahead with Part 27. Solve few problems on refraction by spherical surfaces. So here comes problem 8. In this problem, determine the image formed by refraction. In this problem, determine the image formed by refraction. So here again we have a spherical surface. So this is the object. Okay, so we have to find out the image formed by refraction. So in this case, V is what we have to calculate. So here U, that is the distance of the object, is given as 25 centimeters. This will be negative because it is opposite to the direction of the incident ray. Radius of curvature R is given as 20 centimeter because R is nothing but the distance of the center of curvature from the pole. So this would be 20 centimeter and this would be positive. Mu1 is equal to 1 and mu2 is equal to 1.5. So now we will apply the expression which we derived in the previous slide, that is the refraction through a spherical surface. So we found that N2 by V minus N1 by U is equal to N2 minus N1 divided by R. So now if we put these values which are given above, 1.5 divided by V minus 1 divided by minus 25 is equal to N2 minus N1 divided by R. So we get 1.5 divided by V plus 1 by 25 is equal to 0.5 divided by 20. So we get 1.5 divided by V is equal to 0.5 divided by 20 minus 1 by 25. So this value comes out to be minus 1.5 divided by 100. Or we can say that V comes out to be minus 100 centimeter. So what we see, that the image is formed at a distance of 100 centimeter from the pole, and since this sign is negative, that means this negative sign shows that image is formed on left hand side of the pole. Right? So let us look at the next problem. It says that a small pin fixed on a tabletop is viewed from above from a distance of 50 centimeters. By what distance would the pin appear to be raised if it is viewed from the same point through a 15 centimeter thick glass slab held parallel to the table? Refractive index of glass is equal to 1.5. Does the answer depend on the location of the slab? So this problem is related to the real depth, apparent depth concept. There we saw that the fisherman or the eye was located at the same position, just that due to the presence of the water, that is a different medium, the depth of the fish changed. Similarly here, due to the presence of the glass slab, the distance or the position of the small pin will change. So let us suppose that the distance by which the pin appear to be raised, is equal to x. So that means what is x? X is nothing but real depth, that means the actual depth of the pin, minus apparent depth, that is the depth which we are viewing. So x is nothing but real depth minus apparent depth, that is r minus a. Now we already saw, what did we observe there? We saw that the ratio of real depth to apparent depth is equal to the refractive index of the medium. So here the medium is glass, so this is equal to mu g. So we can say that apparent depth is equal to real depth divided by refractive index of glass. Therefore, we can say x is equal to r minus r by mu g. So what is this real depth? This real depth into 1 minus 1 by mu g. So what is the real depth? The real depth is nothing but the thickness of the glass slab, which is given here as 15 centimeter, because the location from where we are viewing the small pin, that really doesn't matter, because for example, please compare it with the scenario which I showed you in real depth, apparent depth, that is the fish example. There the eye was located somewhere here. So the location of the eye, how far the eye is located from the object, that really doesn't matter. What matters is the amount of water or the thickness of the water which is present there. So here R is nothing but the thickness of the slab which is introduced. So what is the thickness of the slab here? It is 15 centimeters. And this is 1 minus 1 by mu g, that is 1.5. So this comes out to be 5 centimeters. So that means this object appears to be raised by 5 centimeters. Does the answer depend on the location of the slab? No. Right? Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.